In this video we're going to take a look at the ratio test and a basic example. Ratio test is a very powerful test. So if we have a series, suppose that the sequence of ratios of a sub n plus 1 to a sub n has the limit where it equals L. Then if L is less than 1 it converges, if L is greater than 1 it diverges, and unfortunately if L equals 1 the test is inconclusive. So there is a chance that we can get L equals 1, so you want to be careful when you do apply the ratio test. So we're going to take a look at an example on how we draw our conclusion. So we're going to do the series 1 over n factorial. Seeing a factorial or an exponential are two good keys that you'll want to use the ratio test. What we're going to do is we're going to look at the limit as n goes to infinity of the absolute value of a sub n plus 1 over the absolute value of a sub n. In this case, a sub n is 1 over n factorial. So I'm looking at the limit as n goes to infinity of 1 over n plus 1 factorial over 1 over n factorial. So the first thing I'm going to do is flip and multiply. So what I'm looking for is the limit as n goes to infinity of n factorial over n plus 1 factorial. Now, a lot of times what you'll do is you can actually skip this step because you're always going to have a ratio. So basically what you'll do is you'll take a sub n plus 1 times 1 over a sub n and start to simplify. We're going to simplify and see if we can calculate the limit. Now here's where our knowledge of factorials has to be strong. A factorial is the product of 1 up to whatever integer we have here. So this is the product of 1 to n. This is the product of 1 to n plus 1. So let's say n was 5. This would be the product from 1 to 5. This would be the product from 1 to 6. So there's a lot of overlap there. And we're going to take care of that with some canceling. In fact, we'll leave the top as n factorial, but I can write the bottom as n factorial times n plus 1, because that's all n plus 1 factorial is. What that does is it allows me to identify a cancel here. And so basically I've got the limit as n goes to infinity of 1 over n plus 1. That equals 0. Okay, so we have a limit of 0. So we need to see which of these cases it is. It's not 1. That's the worst thing we can have happen from the ratio test because it's inconclusive. It means we need to use another test. We got 0. It means our series converges. So we know that 1 over n factorial converges by ratio test. And that's a basic example of how we can apply the ratio test.